Good morning, everyone, and welcome to Manitoba Agriculture Crop Talk webinar. If you have any questions during this presentation, please type them into the questions section of the GoToWebinar menu, and we will answer them at the end of the presentations. This webinar is being recorded, and you will receive a link to the recording. Thank you.
Thanks, Laurie. I'd like to welcome everybody to the May 4th edition of Crop Talk, I guess our spring series. And as we get going throughout the growing season, we'll be going on a weekly basis now. And it seems like it's always one of the first webinars. We usually get spring weather or soil moisture update, kind of what we've been seeing from last year to what we see this spring. And Timmy Auger is our ag modeler, and he's been on several times and does a great job. So I thought it would be good, especially after what we've been seeing over the past, I always want to say the past month, but it's probably the past 2 months now where we've been seeing such different swings in weather. And so I thought it'd be a great time to get Timmy on to give us an update. And then after that, I've got about 5 or 6 slides about just some of the things that are happening, some reminders, and that should take us through the day. So with that, I'm going to hand it over to Timmy, and we'll get started with our spring weather update.
Okay, thank you very much for that introduction, Lionel, and welcome everyone to this year's Crop Talk. And yeah, I decided to title my presentation "The Pendulum Swing." Going from one end of the pendulum to another, and I'll just give a quick presentation outline, a quick recap of the year that was last year, the growing season and fall, and then just another overview of the past winter and the recent events and its impact, and would wrap up with what to expect. And I always like to also provide just a bit update on what the Ag Weather program is doing. So in terms of the 2021 growing season, again, if there's one word to describe last year, it's definitely drought, and how dry things were, especially in the Interlake and Red River Valley. And this map is showing the amount of precipitation received from May 1st till August 8th. And in terms of the percent of normal accumulated precipitation, again, many of those regions received less than half of the amount of normal precipitation. And that was leading up until around mid-August. And looking at the crop water balance, here I'm showing at Centerdorf for wheat, and over the last 3 years, and this is simply, I'm using crop water balance and a simplified version, which is simply precipitation minus evapotranspiration. So evapotranspiration is the amount of water that you'd expect to lose due to the transpirative demand from crops. And over the last 3 years, 2019, 2020, 2021, you can see a major dry down of soil moisture, of precipitation. I've included the precipitation bar right here for 2021 precipitation. And something that I've always, mentioned is the fact that it's not so much of what happened at the end of the growing season, it's what happened during the growing season and the timing of the precipitation we received. So you notice that between June 22nd here at Centerdorf up until early August, there was barely no significant precipitation. So throughout July, there was barely no precipitation, such that the crop water balance as at the end of July was more than 300 millimeters in terms of deficit. So that we're looking at more than 12 inches of precipitation deficit. Now, note that this is starting from zero, so I'm not considering what you have in the soil at the start of the season. We got some rain in August, which was quite late, especially for the early season crops. And towards the end in the fall as well, early October, we did receive some rain. So we pretty much ended the season last year similar to where we were in 2020, except that last year we did have a greater crop water deficit. In talking about crop water deficit, I always like to just go through briefly root zone available water. It's very critical. The amount of water stored in the soil is very important throughout the growing season, especially at the start. So we get our water from either irrigation or rainfall, mostly rainfall. But sometimes we also do have capillary rise in which water is added to the root zone from high water table. However, we lose water through evaporation directly from the soil surface or through transpiration, sometimes through deep percolation if water, goes leach beyond the root zone. And sometimes we do have runoff if the rate of infiltration is lower than the rate of water that is added to the soil surface. So if we have a high rate of rainfall compared to the rate at which the water can infiltrate, we would have runoff. And we also have the subsurface flow. Now, this is how much is coming in because soil is not a one-dimensional profile, it's a three-dimensional profile. So we do have water coming in, subsurface, and water flowing out. So this is the full crop water budget. However, we do simplify it by simply saying that the amount of water that will be stored in the root zone is based on precipitation because that's the largest contributor to root zone soil moisture minus evapotranspiration, which is also the largest loss that we have. So pretty much my simplified version of just saying precipitation minus evapotranspiration is in no means to minimize the impact of the other factors. But again, looking at the Canadian Drought Monitor for last year, most of the agricultural region of the province were in extreme or exceptional drought last year. And not just in Canada, if you take a look at the US Drought Monitor as well, especially areas around North Dakota, close to the international border. Again, those areas they were also at extreme drought. So heading into the fall, again, I'm sure many folks listening today would know the impact of the drought on yield that we had. But moving away from the growing season in the fall, what we had actually last fall was we had, I would say, quite a normal amount of rainfall for the most part in many areas. This is showing the percent of normal precipitation in the central region at our weather station location. And on the average, again, some location would have more. So areas around Deerwood at about 138% of normal, which, yeah, so about 38% above normal. But then there are some other areas like Gladstone that was just below normal. So on the average, the central region was just at normal amount of precipitation. However, in terms of this fall soil moisture survey that we did, looking using the sensors we buried at the location, and I always put a caveat on this map to mention that soil moisture is highly variable. So this is simply giving a regional snapshot at the specific locations where we have taken, where we monitor. But then again, with soil moisture, you can move just a couple of feet away and it will be completely different. But at our monitoring stations, the Interlake and the Red River area were still much drier. The Southwest slightly at least 60 to 80%, and some locations 80 to 100% of available watering capacity. Now, note that available watering capacity is not saturation. And for that, I always like to use this bucket illustration. Saturation is when you have all these pore spaces filled with water and there's just excess. I always use the illustration of if you dip a block of foam in water and you pull it out of water, you'd have excess moisture draining from it. When, without applying any pressure, when the excess moisture has drained away from that block of foam, you are at filled capacity. However, if you apply extreme pressure to the foam and you squeeze the water out of it, you would get to a point in which you won't be able to squeeze any water out of it anymore. At that point, that's permanent wilting point. Now, that doesn't mean there's no water in that block of foam or in the soil. It simply means that the pressure you are applying is not enough to exert more water, extract more water out of that soil. So the water holding capacity is the amount of water that is being held between the field capacity and the wilting point. So that's what this map is showing in terms of how much is being held in the soil. And looking at this picture of the soil profile, basically with available water capacity, and what we noticed actually at some of our location, I think at Morris and Bronchial last year, especially with the initial rainfall we had in August and what we had in September, was that because many of these locations are heavy clay soils with really, really big cracks, most of the precipitation we received in August and September, some of them actually bypassed the 20 and 50 centimeters and simply just ran through the preferential flow into the holes. But by the time we reach October, and with the precipitation we received in the fall, many of the cracks kind of filled in, and but we're still at quite a bit of deficit going into the fall. Something that was really fascinating last year as well in the fall was the fact that we had our first major snow mid-November, and we had the snow on frozen soil. And it really brought me back to the natural properties of soil in soil physics, looking at how the timing of freezing temperature and snowfall influences runoff and infiltration in the spring. And the top series of diagrams simply shows a topsoil that is frozen, and then when you receive snow on a frozen topsoil, in the spring, when things melt, most of the water will simply run off because the surface is frozen. However, if the surface is unfrozen and you have snow on an unfrozen topsoil, it does have a greater chance of the water infiltrating into the soil when it melts. Now, we are in Manitoba, and I don't think we would likely go through any winter without having topsoil being frozen at all. At some point, it will be frozen. However, the snow on an unfrozen soil actually do act as a blanket, and it reduces the effect of the depth of frost. And that's something that we noticed at many of our locations this year, in which the depth of frost was simply between 10 and 40 centimeters. So the mean temperature in terms of the winter, the winter temperature that we observed, again, winter was definitely much colder at most locations. I think only Killarney and Wawanisa showed slightly above normal temperature. At most locations in the southwest and central, on the average, now again, there'll be some days that'll be extremely cold, some other days would be above normal, but on the average between November 1 and the start of April, many locations in the southwest were just slightly below normal, just slightly cooler than normal. But then in the Red River Valley, close to the Red River area, and in the southeast, mostly at between -1 and -2 degrees below normal temperature. But when you take a look at what had happened just in the month of April, just this past month, and this is just the difference between where we were at the start of April and where we were at the start of May. April was definitely much cooler than normal, and many locations, again, you see, it got much darker, and so many locations actually did receive below normal temperature. In terms of precipitation, again, looking at November 1 to April 4th, because I decided to just have April separately because it's a different ballgame with April this past month. In terms of precipitation, I would also put a caveat with this map, and it's something that we've included on the website. We noticed that this year some of our stations were actually underreporting snowfall, and not just our station, Nevramekanda station as well. And that's because we did receive quite a number of storms this year, and when the wind profile is greater than about 30-35 kilometers an hour wind speed, we do have an undercatch at some locations. So that's something to kind of take note of. We are still looking at putting some correction factors and looking at possibly applying some coefficient that would really just help us adjust for the wind impact. But in terms of what our stations measured, many locations in the southwest was at that 60 to 80%, about 40 to 60% of normal precipitation, which I think it's more than that in the Red River Valley and in the east, between I think greater than 60% of normal precipitation. But I would say for the most part, just looking at the amount of snowfall on the ground, we were literally, I would say, at many locations at normal, if not above normal precipitation. But in terms of what had happened just in April, so looking at the difference between the start of April and the start of May in the Red River Valley and to the east and Interlake, we actually just shoot up from being at about 80 to 100% of normal to being well above normal precipitation. And something that I took this picture on April 12th, just around Winnipeg, and at that time, most of the snow have actually melted, which was quite a good thing, just before the first Colorado low rolled in. But this is the 20-day accumulated precipitation just over the 3 series of events that we've had, and areas around Altoona, Gretna, Winkler, close to the international border, received a lot of precipitation, more than 120 millimeters. And for context, the typical range for climate normal precipitation between April 12 and May 1st is usually between 22 to 26 millimeters. So over the last 30 years, on the average, that's the amount of water equivalent precipitation. So if it comes in as snow or as rain, we would typically receive, let's say, an average of 25 millimeters. Over the last 3 weeks, we've definitely received more than, 5 times more than the typical average. And that definitely has had some implication. I'm looking at this was from Rob Powler. It's been really good. I've had the opportunity to meet with him and discuss some of these numbers with him in the past. And he actually put, looking at data since 1872, the wettest starts to the year, at least in Winnipeg, and looking at the first 4 months of the year. And this year, 2022, actually ranked as in the top 4 in terms of the wettest starts to the year. In contrast, last year and 3 years before, they were actually in the top 4. So we've actually gone, and you take a look at the year 2018, 2019, 2021, 3 out of the last 4 years have actually been in terms of the driest starts to the year, at least in Winnipeg, and I would say most areas in the Red River Valley. But yeah, I know what a difference a year can make in terms of going from starting with only 40 millimeters of precipitation to start the first 4 months last year to going to, more than quadruple to start this year. So in terms of recent events, this is the snow coverage. Excuse me. Yes. Yes, excuse me. So this is the snow coverage over the last 5 days. And this is very important, especially with regards to the flood water that we have. And I've decided not to, again, I'm sure many of you have seen the photos of the flood water, so I'm not putting any photo here in this presentation, but you'd notice, especially around the Interlake region, that we still do have quite a bit of snow cover, as well as areas around, the Riding Mountain Park as well. And that would have some implication, especially as things warms up. So this was the snow cover as of yesterday, and again showing that we still have some snow cover around the Interlake and around the parkland area. So again, with the warming temperature that we are expecting over the next few days, it would have implication in terms of snow melt, especially in the Interlake. I mentioned earlier that the snow we received in November created an attenuation effect such that it simply almost blankets and covered the soil. And this is the data from Bordeaux, just in central region. And it shows the dotted lines is the minimum air temperature. And then the solid lines are the soil temperature at 5, 20, 50, and 100 centimeters. And I've decided to to zoom in into just the soil temperature. And something you would notice is at 5 centimeters, yeah, again, we would expect that it will be frozen at some point. So at this location, the 5 centimeter was frozen just around early December. However, at 20 centimeters, did not get frozen until around mid-February. And that was the extent of the frost because at 50 centimeters, which is this purple line, did not get below, I think, -1. I mean, sorry, did not get below 1 degree. So no frost at 50 centimeters and no frost at 100 centimeters. And this was quite typical at many locations that we observed in terms of the frost depth being out in the range of between that 20 and 50 centimeters, and many locations at 15 centimeters did not observe any frost. Now, the implication is that once the surface thaws out, the soil moisture is expected to be able to move into the profile because we don't have frost at depth. And that's something that I know we've noticed at a few locations as well, especially at the surface 5 centimeters. This is the average soil temperature. So the 5 centimeters you would expect is highly influenced by air temperature. So during the day, you would expect this number. If I'm looking at the maximum soil temperature, this number would go above the freezing point. And at night, once things cools down, then it goes back to being at below the freezing point. So what's the impact of all these water and that we're having on seeding? And I'm showing just the seeding dates for canola over the last 16 years or so. And you'd notice that for canola, it's the dominant seeding day, seeding week. It seems to be the third week. That's this yellow or yellowish orange line. In 2019, the second week was more prominent, and this is across the province, the agricultural region of the province, not really delineating any specific region. And we do have data courtesy of Manitoba Crop Insurance of all these, again, for various crops and seeding dates. So yeah, I know many folks are concerned if things would be quite significantly delayed this year. I think in the valley, there is a high likelihood that things will be slightly delayed based on how much water we currently have. But then we also can't discount the possibility or the ability to have evaporation happening. So over the next few days, I'm sure many of you would have seen the forecast that things are going to warm up from today into the weekend. Actually, I think some locations will be receiving again low 20s by Thursday, Friday, and Saturday. So we would expect to see above seasonal air temperature over the next few days. But something that, again, I know most folks are really concerned about is more precipitation. And I don't think we would have any major precipitation in the Red River Valley, at least. The precipitation coming this weekend would likely be mostly in the southwest and northwest region, and those regions can get up to an inch. But in the valley, I think we would likely see about half an inch or so. Which isn't something we want to see, but at least not as much as what we've had in the last. So hopefully things dries out. And in terms of drying out, evaporative demand is going to be a big factor. And I'm looking at the temperature over the next few days, and I've decided to use the Dominion City reference evapotranspiration a couple of years ago, May 15 and May 18. And this is just the amount, how much water we evaporate from a well-watered reference grass, assuming that there's no water limitation. And the parameters that affect or influences how much water you would lose. And again, I've put May 15 and May 18. On May 15, at that location, we had 12.7 millimeters, so that's about half an inch of water loss. And on May 18, it was barely up to 1 millimeter. So the main factors that influences the rate of evaporative demand is radiative energy, again, what the solar radiation values are for those days, the temperature, and typically you want to have a very good or high temperature gradient. So that's the difference between the maximum and minimum temperature. When you have a large temperature gradient, a large temperature difference, it actually helps to drive evaporation, and that simply means you have a cloudless sky. And compared to like on May 18, where the temperature gradient was very close, just about 3 degrees difference, and that's why again it would have been a very cloudy day, and reference evapotranspiration will be quite low. Another major impact is the average relative humidity. So when the humidity is low, it means that there is more space in the atmosphere for water to evaporate into. Compared to when the humidity is high, it means that the atmosphere is almost saturated at that point, and you don't have a lot of space for new evaporation to get into. And the last weather parameter that also influences the rate of evaporation is wind speed. On both days that I'm showing, there wasn't a lot of difference, but however, we do know that with higher wind speed, it helps to dry things faster. So we can hope that we would have quite a bit of evaporation happening, especially around the valley with the short-term weather forecast that we would be having. If you're interested in seeing what the heat evapotranspiration values are, this is the reference. We have it on our website. It shows the last page of the summary shows how much reference evapotranspiration occurred at various locations where we monitor. So yesterday, for instance, it was mostly about 3 millimeters, which hopefully as things warms up today and into the weekend, those numbers would keep rising. So in terms of what to expect longer term, this is the 1 month forecast probability, and it shows around Manitoba. We don't really we have equal probability of being either above or below normal. So when there is no color code right here, it means that we have equal chance of being either above or below normal in terms of our temperature of what to expect this month of May. Looking at a longer term 3-month forecast probability, it's still the same. Again, the models are not showing any strong probability one way or the other. So again, it's like a waiting game. We have to wait and see what happens. But for now, we don't have any inclination as to if we would be above or below or just near normal in terms of temperature. And for precipitation, again, sadly, it's the same, or not sadly, but it's the same. We really don't have any inclination. But something I'm actually watching and being curious of is looking at this brown patch around Alberta and Saskatchewan, although it seemed to really just end at the Saskatchewan border, and then even south of us in Minnesota and North Dakota, it's showing quite a dry patch. So those areas are showing about 40 to 50% probability of having below normal precipitation over the next 3 months. Manitoba isn't showing anything in terms of the probability, but it will be really interesting to watch. Hopefully, again, I know with the precipitation we've received so far, it can only carry us for so long before we need those timely rains again. For now, we just hope that things dry out, especially in the valley. Out west, in the southwest and northwest, I think things are pretty good, except for areas along the river. So areas along Souris River, for instance, maybe those will need a few more days of drying. But I would say for the most part in other regions, they should be pretty much good. I always like to end this conversation with looking at the Manitoba Ag weather stations and some of the new things that we are doing, or at least the things update from our network. As many of you know, we have these stations installed, over 100 of them installed now, and this shows the distribution of our network of stations. Last year, we installed 4 new stations, one at Brandon, that's in the southwest at Assiniboine school at the community Assiniboine Community College. We installed 2 in the Interlake, so Clag Hill and Petersville had new stations installed last fall, and Richer in the southeast as well. This year we are planning to install about 6 more stations, and we have actually made some contact already. So Brookdale, Erickson, Amaranth, Oakland, and either Angusville or Ashan in the Interlake will be installing as well. In terms of data access, information access, again, feel free to visit our website. One of the popular pages that we keep having visitors go on to is our current weather condition interactive map. And if you go on there, you can actually see what's happening current. It's updated every hour. And you can see, again, clicking on any of the tabs, air temperature, humidity, precipitation, wind speed, it shows you what's happening right at the top of that hour. And with that, I want to thank you, and I'll be happy to take any questions that you may have.
Hey, Timmy, thanks for the presentation. There has been some questions coming in, so I'm maybe just going to start from the first one. You had showed those maps or charts about ground, how far the ground froze this year. I guess the question that came in was, how far would a normal, in a normal winter, would the ground have, would the ground normally freeze?
Yeah, no, that's really great question. And in a typical year, well, I don't know if there's a typical year now, but it depends on quite a number of factors. And one of the most important factor that determines the depth of frost is the ground cover. So if we have, let's say, vegetation on the soil surface, again, it's tend to attenuate that ground cover. For the most part, many of our location would see, and I should also mention the timing of snowfall, I think, is also a big factor. So in years when we've had the soil freeze up without having any snow cover on it, the frost would actually go as deep, or at least we monitor at 5, 20, 50, 100 centimeters, and we would easily get frost at 100 centimeters. It usually lags, and it will take a while. Usually maybe around January is when we would have the 100 centimeter frost at 100 centimeters, but it will get there. In a year like what we had this past winter, when we had snowfall first on frozen soil, it did attenuate that effect. So I'd say some years we've had frost, actually many years we've had frost at 100 centimeters, especially if there is no very good snowpack to act as to attenuate that frost effect.
Okay, good. Another question is, what is the best method for someone to estimate root zone saturation just prior to planting? Is there an inexpensive or relatively accurate device available, or any comments on that?
Yeah, I would say to determine root zone soil moisture before planting, I don't know if there is any easy way. Most things that is publicly available and free would be derived from models. And not that they are inaccurate in themselves, it's just because of the spatial variability of soil moisture. So, and most models won't go down to field specific data points. They would likely provide an aggregated average over, let's say, a 6 mile, or over 6 miles or so. So there's really no easy answer in terms of an inexpensive way. Part of what we do, like I said, monitoring soil moisture, it's at a specific location. But one of the things that we are looking at doing at some point is actually using some of these remotely sensed data from satellite imagery and actually disaggregate them and see if we can get down to maybe not a quarter section level, but at least within a section to see how well we'll be able to monitor average soil moisture. And I use the word average, with, quote and unquote, because an average soil moisture doesn't mean that everywhere on that field will be at that moisture level. You may have a low point that most of the water just runs into and will be much higher. So yeah, no, unfortunately, there isn't any easier way without having a sensor in the field itself. But then many of the sensors that would give you average soil moisture over a quarter section, for instance, are quite expensive. One of the ones that comes to mind is the Cosmos rover, and it's installed and it uses the natural neutron emission from the soil to estimate soil moisture. Our stations uses just a single probe installed at a specific location, and oftentimes to determine the average, you'd have to actually walk across the field and take 40, 50, 60 samples and just determine the average that way. So yeah, so unfortunately there is really no way, and many of the satellite data as well only give the surface soil moisture information, depending on the type of soil, how coarse or how fine texture the soil is. They only simply sense the top, say 2 to 3 inches of moisture, and then you'd have to use a model like I showed earlier on, using the crop water balance, for instance, to estimate what you would have at depth.
Okay, good. This question seems to come in quite a bit when we talk with you, Timmy, but any comments on the wind? Seems like every year we're having more and more wind, and what are we looking at for this spring?
Yeah, no, unfortunately, there isn't a wind forecast that goes like far in advance. But basically, I would say for wind, over the last few springs, and actually, I gave a presentation some time ago showing just the average wind speed and how they seem to have ticked up a little bit, as well as the maximum wind speed. Last year, I think, was much higher than what we've observed in the past. So yeah, I think we seem to be having maybe an uptake in terms of the wind gust. I don't know why, if there's any specific reason for that necessarily. But when we look at historical data compared to what we had at least over the last couple of years, and even compared this last winter as well, yes, I think wind seemed it seemed to gradually becoming a factor. Oftentimes we discuss mostly precipitation and temperature, but I think gradually wind seemed to be a factor. Now, with how much water we have in the valley, I think having quite a bit of wind can help to drive the evaporation rate a little bit. But I don't have any specific inclination as to what to expect, let's say, in the longer term in terms of wind speed.
Okay, and this kind of follows that one. You had an animated temperature and wind forecast. Is that publicly available anywhere? Or?
Yes, it is. It's actually one of my favorite animated forecasts that I like to use. It's windy.com. I think this is what is being referred to. So yeah, it's through windy.com. And one of the reasons I like it is because it also shows you different models. So this is the ECMFWF model. You can also use the GFS model. So you can select which model and see how the models agree or disagree. So yeah, so windy.com it's publicly available, although there's also some subscription and stuff if you're interested.
Okay, and then I guess a couple questions that are kind of related here. I guess the last fall rains, because we were so dry, did they actually help much in regenerating the soil, or basically is it gone? And I think it might be a comment regarding, you were talking about the rain went down the cracks. So is that it? Moisture going to be around for this spring?
No, so basically what happened last fall, and it's something quite interesting to observe at some of our stations, where we noticed that and at locations that have those really big cracks. I know at Centerdorf, yeah, the station showed, I think Centerdorf received about 2 inches of rain in mid-August, and you'll barely see any increase at 20 and 50 centimeters, but at 100, you see the uptake. Now, that moisture, and typically with any location, you would expect that water would always fill in a soil layer until that layer gets to field capacity. Sometimes you would have, there are so many other things that happens with in terms of soil percolation and how water moves in soil, but typically once it gets to field capacity, that's when it starts. It's like a bucket. Once the bucket is full, and full in this sense, I'm not talking about saturation in terms of everything really, like that block of foam having excess moisture, but once it gets to field capacity, that's when it starts to drain into the lower profile. So ideally, you would expect that in a typical rain, you would fill in the 5 centimeters first. Once it gets to field capacity or close to field capacity, it fills in to the lower depth at 20 centimeters. Now, the precipitation we received last fall, again, this is quite a generic statement. It will be different at different locations, but some that had that preferential flow down to 100 centimeters would easily go into groundwater. Again, depending on the type of aquifer it is. So we would actually, once the 100 centimeters gets to field capacity or close to field capacity, it would also allow the water to drain beyond the root zone. However, the soil would hold on to the maximum amount it can hold on to at that field capacity without any drainage occurring. At other locations where we did not observe the preferential flow, water would simply fill in that 5 centimeters first, move on to 20, and I think that's what we observed, or at least what likely happened in most areas in the Southwest. If I can quickly just zoom to the fall soil moisture in the South. Yeah, in the Southwest, with our soil moisture falls, shows that the Southwest did have 80 to 100% of water holding capacity. Now that's because the precipitation received in the fall mostly stayed within the root zone, but in the Red River Valley and in the Interlake, most of that precipitation likely either did not stay in the root zone and simply went down to groundwater. We don't have groundwater measurement at any of these locations to be able to ascertain, to be certain that that was what happened. But in a way, not that we want any drought, but if many of these locations had been saturated, and that's, again, this is just what I expect to see, that once the surface profile thaws out at some location, some of the excess moisture that we are seeing would likely infiltrate, especially because at depth, many locations are showing unfrozen soil at 1,500 centimeters. So once we have the 5 centimeters and 20 centimeters, that's especially in the interlake, once we have them thawed out, I would expect that the soil still have considerable amount of space and capacity to store more moisture.
Okay, and are there any regions of Manitoba where the ground froze before the snowfall arrived?
No, I don't. I've not really checked specifically. I know I checked quite a number of stations, not all the stations. So I don't know if I can say all the stations remained unfrozen before the snow arrived. But I think there's a very good indication that that was what happened, because for the most part, last fall, October and early November were actually quite warm. And so I would expect that, yeah, I think when we had the first snow, most locations were not frozen at that point. But is it possible that 1 or 2 locations were frozen before then? Yeah, that's a possibility. But I would say generically, most locations were unfrozen at that point.
Okay, and one more comment. Thank you, Timmy, for having 2 bison grazing on the root zone plant route outline. Us bison producers are keen to see our animals everywhere. So great. Thanks, Timmy. That was a great presentation. Spurred a lot of good questions, and thanks for answering them. And Lori, if you could turn the screen back to me. I wanted to go through a few slides here before we end the webinar for today. Last couple days, I've been out looking at some winter wheat and fall rye fields. Actually, most of them have been fall rye fields, and they're looking like they made it through winter okay. I did dig up a few plants, and just a brief review of what to look for when you do dig up the plants. You can see the last year's roots that created all that growth that was on the previous slide. But look for these nice shiny white roots that are coming out of the crown. You can see that these fall rye plants made it through the winter fairly good and no major issues. Lots of nice new white growth from the crown for the root systems. And if you look closely enough, right there looks like a new leaf coming out of the crown too. So looks like the plants are even though we've been getting you know, cool weather and snow and wind, it looks like a lot of these plants made it through the winter okay. There was a few spots in the field where high areas where the wind maybe blew off and the plants were more stressed, that maybe they aren't quite as aggressive yet. But it's interesting what Timmy said regarding the frost in the ground, and the ability for those plants to survive the winter was probably a little bit easier because it didn't freeze that much in most areas. I'd like to mention that this year we're going to have our crop scouting panel again. So as we go through the growing season, if you've got questions for any of our specialists, it's really good of them to come on and answer questions as we go through the growing season. So if you see something through the week that you have or want to address to the specialists, send me an email or be prepared to you know, ask the question as we're going through the topic for next week. Just some information regarding the ag adaptation specialists. There's myself, Terry Buss, Earl Bergen, Amir Farouk, and Nicole Clausen. Those are the people that you can contact during the growing season or throughout the year if you have questions and need some help getting things figured out. Also, our livestock people, there's Pam Chesko, Elizabeth Nurnberg, and Sean Quebec. There's their contact information. And again, if you've got any questions dealing with forage, livestock, pastures, give these people a call. Definitely can give you a hand figuring things out. Our MASC offices, that's where they're located. So if you need to stop by and talk to somebody, whether it's crop insurance or get a hold of somebody or regarding something going on in your field, you can always contact these offices, and they can get in contact with or help you get in contact with people that can give you a hand. A reminder, the Livestock Feed and Transportation Drought Assistance Program application deadline is this Friday, May the 13th. So you need to have your information in by the end of that day. So please remember that date. And if you're talking to producers, just throw a bug in their ear if they haven't put their information in yet to definitely get it in, or at least contact one of the MASC offices and find out what they need to do. The Field Crop Production Guide is available for 2022, and it's available again at all the MASC offices. If you're needing copies, you could also contact any of the crop production people that I mentioned. And if you need bulk orders or you're wanting to get a number of books, we could probably assist you fairly well if you contact Kim Brown. There's a number of books in Carmen, and we could probably get them mailed direct to you. but Kim would be a good person to contact there, or contact, again, any of the crop specialists. And I don't see if there's any more new questions that have come up. So that'll be Crop Talk for this week. I'd like to thank Timmy for giving us a weather update and soil moisture update. And I think as the week goes and it gets warm, like Timmy's saying, we're going to see more and more guys looking at doing stuff and maybe seeing some of the water going down in some of the areas where it's fairly wet. So thanks for attending, and we'll see you again next Wednesday, May the 11th.